did just a lecture part of signal and slot. I did that lecture because we're going to use signal and slot in our coming chapters. Also in this chapter, because up till now we are up to the part where we can move this player rectangle side by side and even up and down. But what I really want is when I take this player rectangle up, I want this to be pulled down by the gravity. It should feel like it's been pulled up by a thrust. So whenever I push one up arrow key, it should go up like a bush. So I shouldn't be able to go all the way up like this, like keep on pressing the up button, but I just want to give it a thrust, and even after some time I need to go down again. It's just like a gravity. It should be pulled automatically down without any user input. So without any user input, if I want to be pulled down, then I need to set up a timer to do it for me, because I'm not really pushing it down, right? So it is the gravity working on this rectangle. So for that, let's start implementing. Let's close that window. So I'm gonna add a variable called y speed, because we already had x speed for moving side by side for our rectangle, but for moving upward we don't have any variable, so I included y speed. And my second variable will be gravity, and I'm going to show how this works. So before anything else, I'm going to add a function which is also invocable to move upward. So we have for moving left, moving right, now to move upward. So I'm going to name this void, not move up, but let's keep it name as apply thrust. So in apply thrust, what I'm going to do is I'm going to set my y speed equal to some value, let's say -30. So what I'm saying, like my y speed, if I push the arrow key up, then it should be going towards upward. So the window coordinate starts from 0, 0, right? So we are somewhere in the 600, 700 pixel downward for the rectangle. So to move towards 0, I need to subtract some value. So if I subtract -30, it will change its position to go closer to 0, but it will give you a feel like it's moving upward, but actually we're just changing the position of the pixel so that it looks like we're going upward. But instead of giving it a hard-coded value, I'm just gonna give a variable. So for any readers who comes here to read my code should be able to understand what I'm doing. So for this, I'm gonna say max thrust. So our max thrust going to have this value -30, and I'm gonna say max thrust here. And also for the gravity, I'm gonna give value 0.5. So I'm gonna tell you why did I use 0.5 in gravity and how we are going to use this. So before anything else, let's create a function called void update state. So what this function does is this gonna update the position of our y. For example, if I push the up arrow key, our y, the rectangle will move to vertical distance by 30 pixels. But what do we want to do is to update it and pull it back down, just like how gravity pulls things down. So it should be pushed down automatically. So there should be a change in state. So for that, what I'm gonna do is I'm gonna say our y speed should be our current position actually. So I want to change our current position, which is our m_y should be changed to our y speed, and then I want my gravity to work on it. So to current position y. So what is happening here is I'm changing my position of current y coordinates. So our speed, which is -30, is being added to our current position. So whenever I keep on pushing the up arrow, it should be traveling 30 pixel up, 30 pixel up, 30 pixel up similarly. So, and adding the gravity means that 0.5 pixel is the positive value, right? So it is bringing it downward because our coordinate starts from 0 and the value goes downward. So if you are subtracting some value, it will tend to look like it's going closer to 0, which is giving a feeling that the rectangle is moving up. But if you add a positive value, what happens is like it should feel like it's going downward. So we are applying gravity, and I'm giving this a small value because we're going in a loop, so it should look like it's smoothly falling down, not like a jerky some pixel travel. It should like the rectangle should travel each pixel, and we're gonna set a timer to travel that pixel. So, and what else I'm gonna check is if whenever the rectangle is falling down, if it's moving down, it shouldn't crush the bottom of our window. It shouldn't fall down and go beyond our window, just like we didn't let it go outside of left side and right side. Similarly, I don't want this to go further below the bottom size. So for that, I'm going to check if our current position is greater than our bottom max. For that, I'm going to create double or maybe I can use this variable instead, our bottom y. So bottom y. So what I'm checking is if my current position is greater than the bottom y, which is the window's height. If it's going beyond that, that means our rectangle is passing the window. We are not able to see where it has gone somewhere down the window, right? So if it's like greater than that, then I want to change my current position to be our bottom y. So what I'm saying is if our current position is trying to go beyond our bottom y, immediately change it to bottom y. So it just stays in the bottom and doesn't pass beyond that. And what I also want to do is whenever this happens, I want to imitate this change, y change. So whenever this happens, like for example, my y position is changing with the speed, right? And then I'm applying gravity to make it fall. And then if it has gone beyond the window, then it should immediately pull it back to the window bottom. And I want to change this. These changes should be tracked down. Why did I create this function? To keep on updating it every second. Whenever I push the up arrow key, it should go by 30 pixel upward. And then when this change happens, it should immediately fall back, just like gravity. When you jumped, gravity will work and just pull you down, similar to that. And this is going to be our slot. And what really is slot? We saw that in our previous lecture. So before anything else, I'm going to say that slots can be public or private. Slots are nothing more than a C++ functions. When I said about signals are just like C++ functions, but it doesn't have a definition. It doesn't have a return type. It's just existing because its sole purpose is to give you a signal, nothing more. It doesn't process anything, while slot has the process. So this is going to be a public slot, but you can either keep slots private or public as per your need. I'm just keeping it public for now. And before everything else, because our rectangle will be pulled down in certain time, so I want to add QTimer object. So Qt provides a lot of objects. So here is include QTimer here, just like we included QObject. So this is a object, right? So we can, if it's an object, then I want to initialize it here in the private variable section. So how do we initialize is writing the QTimer class name and writing as instance name, let's say time. So now I initiated my timer as an instance. Now I want to set a timer for certain time that keeps on changing. For a certain time, I'm going to say like start the timer, and then when the timer is set out, like, or timed out, you need to check for the updates and run this function again, and it checks if these values is like changed or something like that, and then it again goes on a loop. So let's see. And to set up a signal and slot, I'm gonna go to our control.cpp, and then inside our constructor I'm gonna start writing my signal and slot mechanism. So for that I'm gonna use connect function, which connects two objects. So our two object is going to be one timer, and second is our controller object, this object, right, which has the Y position, because that is what we're trying to track and change. So as I have explained to you that when you start a connect function, we need to specify what our sender is. So our sender is time, and should, because the connect text, if I go inside connect file, which is Q object or header file, it has a pointer as a parameter, so we need to send it as an address. And for that we're going to use and time comma, this is time is our sender, and then our signal is going to be, let's see what signal our timer has to offer. If I go to controller attach and go to timer, put my cursor there, and then hit F1, and if I scroll down the documentation, there should be a slot here. So sorry, signals here, timeout. Yeah, so I have a slot called timeout. So what it does is, so this timer signal, what it does is, it has a function here as a public slot. See, this is a object given by C++. This is not something that we created. So it comes with pre-built slots and signals. Just like we created slots and signals for our controller class, this is a class given by C++. So it has also predefined slots and signals. So we have in slots, it has start function, which is going to start the timer. And whenever this timer is stopped, let's say if I started with 10 second, when this 10 second is completed, it's going to immediately emit a signal, which is timeout. So let's go and try this. So in controller.cpp, I'm saying like connect our time object, and our signal is, I'm also passing the address because all the parameter is pointers. So QTimer timeout. When timer emits this signal, I want our controller class. So and controller, instead of and controller, I just write this. So why did I write this? This is equivalent of saying and controller, because this means that we are already inside controller class, right? So I'm just saying this, which returns the address of this class. So we can directly write this. In the previous lecture, I didn't write any this because I did it inside main.cpp, right? So when I'm doing it inside main.cpp and not inside that specific class, then I need to use that class name. If I was like, for example, if I was inside time class, then I should have written this here, and then the name of the controller here, instead of writing this. So because right now we are inside controller, so I'm writing this, which returns the address of the controller. So whatever class you are inside of it, if you use this, that gives the address of that class itself. It's just a C++ function. It's a C++ feature, okay, not a Qt specific feature. So this, and then I need to connect a slot to this timer. Whenever this timer is called and this signal is emitted, this object's any one of the slots should be executed. In our case, our slot is, just now we created a slot which is called update. So I want to update it. So for that, I'm going to give the address of our controller class, which has a slot update state. So what I'm saying here is, whenever there is a timeout, keep on updating this, connect with this, update it. So I'm going to start a timer here. So for timer to start, I'm going to say time, which is our instance, and then we have a start function. So dot start, and then I'm going to say start it every 16 millisecond. So why am I saying 16 millisecond? To make it 60 fps. For those who don't know what fps is, it's a frame per second. And what I'm saying is like run this update state 60 times in 1 second, because if this is going to get timed out for 60 times, because it's just a 16 millisecond, right? 16 millisecond will occur 60 times to complete 1 second. So this is going to run 60 times, and the change, the rectangle that will be looking that looks like it's falling will be running on 60 frame per second. So it will look like it's slowly falling, just like gravity is pulling. So for that, we are automating it using the timer. So if I run this, let's see, nothing is happening. So maybe I haven't included this in our QML. See, in our QML, I still have the old code which we did in our previous lectures. So we already changed the control to our controller class for our left and right key, and we didn't change it for the up and down button. So I'm gonna remove this down because I don't want our rocket rectangle to go below window. So I only want the thrust to the rocket. So I only want to move up. So I'm gonna call my function control dot, which function are we calling here? We're calling the apply thrust function, which is going to set the max thrust value, which is going to send it up. And then this will, what will this do? This will change the value of y. And then when the value of y will change, this function is always running, because like it's going 16 millisecond, it's gonna loop in. So it's gonna check if the y is changed. If image changed, then it's gonna set the value again of all these things. So if I go here, in main.qml control dot apply thrust and run it, whoa, it went out of the window, it didn't fall back. So let me see what I did wrong here. So let's go back to our controller h. Everything looks good. 0.5 emit y changed, bottom y, this all looks good. In our controller.cpp, we connect our time with timer. Timeout will be in 16 millisecond. Update state, that all looks fine. Then we should have problem somewhere here. Max thrust, this would be max thrust. So we keep on adding it to our current position. That will gonna make it fall. And then, this will be y speed. See, this is how I debug. See, I went through my code. The code was not working as expected. I knew what part was not running, because going horizontal was covered by this function. So you already know where to go and debug your code. I don't want to cut this clip out of the tutorial, because I want to show you how you need to debug, right? You don't have to go clueless if your code doesn't work. Normally YouTubers push their clean code, nicer code, which looks like they know everything, but it's not how it works. You need to keep on testing your code, you need to keep on testing your application, and there's going to be a lot of bugs coming. So now here, our current position is changed by y speed, which is coming from max thrust, which is -30. So our current position is changed. Whenever we push the button, it goes up. And now what I want to do is I want to apply the gravity, right? So I want to change this y speed, which is going up, to go down. So I'm add 0.5. Sorry, I have the variable for that, right? So what I'm saying is, when it goes down, if there is an update and I haven't clicked the up arrow, what it's gonna do is it's gonna add 0.5. So our origin, which is like the pixel value, is from 0 to our window height, right? So if we subtract it, it's gonna go up. But if you add value, then what's gonna happen? It goes further away from 0, making it look like it's going down. So that's how it works, but it is going down by a small value. You notice that the gravity is 0.5 only, but it runs 60 times in 1 second, making it look like it's falling pretty quickly. And for the thrust, why did I put the big value? Because we are only going to push it once, and it should look like it's like going with a thrust, just like that, with a boost. I hope this will work. So let's run it and see. This is running, this is going good, but the jump is too high. You can see this is too big jump. So I want to reduce the value of our thrust. So I'm gonna keep it 10 pixels. Nice. Okay. This seems fine, but I'm gonna keep it to 20 or 15, let's say. So our thrust is going to be 15, and immediately it is connected to the timer. So timer is running off in 16 milliseconds, and every 16 milliseconds it's checking for update, and update state it's checking for y change. So y is changed. So what is it happening? The gravity is being added, and the added gravity will make it go down, and it checks if it's trying to go below the window, and if it is greater than a window, it automatically pulls down to the size of the window, not letting it go beyond the window. But I also noticed that in our here, I don't see the rectangle. See, it's halfway there, halfway inside. So what I'm gonna do is I'm gonna go to our controller and see what's wrong. Okay, this value should be our bottom y. So our bottom y and our current position of y was different, which was the current position was meant to be the actual rectangle's position in the initial state, and that should be equal to our bottom state, which we need to fall back with the gravity, which was greater. That's why it was going beyond the window. So if I replace this, yeah, it is in the window right now. So if I push up arrow key, we have a thrust, and whenever I leave my arrow key, it falls down. And if I can go also to the side, and it has a gravity, so you cannot stay up in the air, so it's gonna fall down. And if you want to keep moving up, it goes up, and it also goes up beyond the window, which we're gonna fix it in the coming tutorial. Okay, thank you so much. I hope this helps. If there is any confusion, please let me know in the comments, and I'm gonna solve it for you. I'll see you in the next one. Thank you.